All right, so let's talk about WinDebug. Now, originally, I used the original version of WinDebug on Server 2016 and this product called LiveKD from Mark Rusinovich, because the thing about WinDebug, the point of WinDebug is you can debug userland code with WinDebug, but things like OllyDebug are much nicer. But the point of WinDebug is you can debug kernel mode. But if you were to debug the kernel and say put in a breakpoint, the way we did in doing that debugging those games, if the kernel hits a breakpoint and stops, your machine is dead. Doesn't respond to the keyboard, the mouse, or anything, so that's useless. So the way Microsoft originally planned this is you would have to have two physical computers and you would connect them with a serial cable, a 25-pin serial cable, which only the older people among you will even remember existing. And they left it that way for a long time. Then around the time of Windows 8, they started theoretically supporting connecting those two machines by something like TCP, which really didn't work very well, but it was better. And anyway, Mike Rusinovich figured out that he could write this tool called LiveKD. Mark Rusinovich is wonderful. He's the smartest guy in the world about Windows. He wrote the sysinternals toolkit. And what LiveKD does is it makes a memory dump of the kernel memory, and then you can look at it. You can't put a breakpoint in it and run it, but you can at least examine the kernel on one machine without having to have two machines connected by some goofy cable or something. And that's a big step forward. And so I figured out how to do that. The only way to do that was to download WinDebug from the Windows Software Development Kit tools and then install this thing called LiveKD. And you could then observe the kernel in this tool called WinDebug. But when I taught that class, I had a Microsoft engineer in my class, which I didn't know, and he came up and said, oh, there's a much better version of WinDebug out now called WinDebug Preview, and it's only for Windows 10. And I tried it, and it is better. It's still not as good as OllyDebug, which is really friendly, but it's a lot more friendly than it used to be, so I'm going to start with that one. But you have to have a Windows 10 machine, like the Flare VM. And then you just go into the Windows Store, which is here, the Microsoft Store, and you can install WinDebug Preview. It's free. And when you're done, you can launch this thing, and this thing has LiveKD built into it. So you can debug the machine that you're sitting on if you like. Now let me close some of these other windows to make things less crazy around here. All right. So let me get my instructions. All right, so I'm going to debug Notepad. First, I'm going to do Userland Debugging. So in WinDebug, just like we did in Olly, you can launch a program here. So I can do File, Launch Executable, and then I can launch, say, Notepad. It's one of my recently used things up there, notepad.exe. Open. Okay, and now it shows me stuff happening as it launches Notepad. And so it shows me the libraries that are loaded, like cryptbase.dil and profappy.dil and so on. All these libraries are used by Notepad. By the way, Notepad is not a simple program at all. I thought it was, but when I did this project and students did it, I found out there are in fact a lot of complexities to Notepad, and in fact many different versions of Notepad, far more than you might imagine. Anyway, those are the dils. So notice that ntdil is one of them up here. First comes Notepad, and the second thing it loads is ntdil. All right, that's the user mode face of the Windows kernel. All right, and so if I go to Process Explorer and look at the dils, I'll see the same thing. Process Explorer. And I go down to the bottom to find Userland, which is this purple color. And in here is Notepad. And here's the dils. So again, you'll see, for example, Advanced API dil is here. And if I find ntdil, for example, and I look at the properties of ntdil here, it will show me its load address, which is this FFE761 is in the middle of it. And if I go to WinDebug. That's this number here, FFE761. This address right here is where it's loaded, and that matches what you see here in Process Explorer. All right. So now, if you want to see what happened, if you scroll to the bottom, it has hit a break instruction and stopped. Now, this is what debuggers do. They put in a break instruction and stop so you can see what's going on. I see somebody here about Notepad. Support for multiple line endings. Oh my goodness, okay. Yeah, I know. I found that there's a lot more to it than I thought. Anyway, so it stopped at a break instruction inside ntdil. ntdil load drop do debugger break, something like that. Loader p do debugger break. All right, so I can view the stack. This is showing me the number of threads that are running, but Notepad's only running one thread, and that's kind of boring. So I can view the stack instead. And now I get the stack, which, by the way, is the same thing that Ollie Debug put there. And so you see here, I'm currently in this ntdil in this ldrp do debugger break, and that was called for initialize process and initialize and initialize thunk. So this is the dream within a dream function. This the initialize thing was called in this one and this one and this one. I'm 5 layers deep in functions calling subfunctions right now, all within ntdil. Now we can look for functions. We can look for symbols in here with the X for examine. So it's X notepad bang star. That will look for symbols in the notepad process, and as you can see, there's a lot of them. Import description and file dialog events and memset and many, many other symbols. These are labeled locations inside Notepad. If I want to look for a shorter list, I can put star main star, and now I'll see the ones that have the word main in them. And the entry point is win main right here. That's where it actually enters the program. All right, so I could set a breakpoint at win main, and what I'm doing here is userline debugging, just like we did in Ollie Debug, although it is 64-bit. So that puts a breakpoint at win main, and if I do a BL, it will show the breakpoints. Breakpoint list, and here it shows. I have a breakpoint there. So now I can resume execution with G. Remember, right now I've stopped in ntdil because it stopped right at the beginning of the program. Oh yeah, you had to get the hat because the side light is irritating my eyes. And there, now it has moved forward, and now see it stopped at notepad win main. And see the higher levels are true. Now it's got user thread start, threaded thunk, CRT startup, and win main. So I've moved forward and started the process, started the program, made it a bit further. Now I can see the loaded modules with LM, and these are all the modules, Notepad itself, and all the DILs loaded in memory like crypt base and so on, and where they're loaded. And notice that just a couple of them have Microsoft symbols loaded, which means I can find all these alphabetically named symbols in them. The others do not have the symbols loaded yet. All right, and I can do a stack trace to see where I am with K, and all that does is reprint out the information that I have in my bottom right pane anyway. And now I can find, you may remember what we did in API Monitor. We looked for the create file methods, and we were able to find the file name that used by Notepad to create a file. So we can find that with xntdil, looking for symbols that include the string create file. Now, my stream has got all blurry here. Is it okay for you folks? Well, let me know in the chat if the stream is bad, and I'll try and find something to do about it, but I'm hoping it's just me because I'm glad it's good for you. That's usually my stinking internet's not much good here. All right. So here's the things with create file. There's 4 of them, and one of them is ZW create file. So I can put a breakpoint in ZW create file and resume execution. Okay, and now it will hit the breakpoint and show you this long list here of the steps to get there. And again, I can dump the stack trace up in the main window if I want to, and you can see I'm now 30 layers deep in the stack, and that's 30 hexadecimals. That's 48 layers deep in functions calling functions. Pretty outrageous. And there's a number at the start of this which indicates the thread number. This is thread 0000. All right. And minus will show you the number of threads. And nope, apparently not. Oh, the tilde character. Okay, shift backtick. There. So there are 3 threads in my notepad, apparently. Currently I don't understand why it says suspend and then it says unfrozen. But anyway, there are 3 threads. And I can delete all the breakpoints with BL. And so then you can find a flag here to show you made it that far. That's the basics of Userline debugging with WinDebug. But the real fun is to debug the kernel. So let's take a look at that. Or yeah, I think I'm going to skip this source level debugging and go into kernel debugging, which is more interesting. So here's the story. Your user application like Notepad or Word or something is out here. Then it calls kernel32.dil, which is the typical library you load and use. That calls ntdil. This is called the the private library. It's called the private API, which normal people are not supposed to use. Only Microsoft insiders are supposed to use it. And then, that's why a lot of malware likes to jump into it directly to help confuse people. That then jumps into kernel mode and calls the actual kernel itself, which is ntoskernel.exe. And that accesses kernel data structures that have information about drivers and such, and actually executes kernel mode commands like direct control of hardware. So you can examine the kernel itself. So if I use, I think I'll just close WinDebug for the moment. All right, so if I go to C Windows System 32, I can open it in CFF Explorer. I'll just do it this way, CFF. All right. And I can open C Windows System 32. All right, what is this nonsense? This PC, C. Windows, okay, there we go. System 32 and NTOS kernel. There it is. All right. And so that's the kernel, and we can see a lot of functions in the export directory there. And here they are. All these things down here, these are the kernel functions you can call through the API, like BGK display character, get console state, copy, read X, and on it goes. Those are the ultimate functions which the kernel can do, and that's what all your programs do, is just call these functions to get everything to happen in your program. All right. So now if we want to debug the kernel, we have to turn on local debugging. This is a command line setup for the, it is a boot configuration setup. It used to be in a plain text file in Windows XP called boot.ini. Now it's done with this binary boot configuration data edit, bcd edit /debug on. And then debug settings, local. All right. Now if I run Windows Debug Preview as an administrator, well, I have to restart after doing that. It doesn't take effect until reboot. Don't need this anymore. Don't need that anymore. All right. All right. Okay, now I want to run WinDebug Preview as administrator. Okay, there we are. Running as administrator, that's good. Now File, Attach to Kernel. And I can attach over these various connections like USB and serial port and such, but I want to go local. No debugger configuration, just click OK, and I will be examining my local kernel on this machine. So here I am, running the debugger with a symbol search path, and it'll eventually, now I can do LM to see loaded modules, and I see a few of them here. All right. And there is an NT link, which is the kernel itself. So I click NT. Now I get a few more lines. And if I hit the functions, I will see all the functions in NT, which we listed earlier. There they all are, at least all the ones that start with A. This is a really sloppy user interface here, which I don't know why they bother with this nonsense. Instead of just having a command line tool, they have a GUI tool that doesn't paginate correctly. So you have to scroll back here, and now you can hit B and C and D and get other lists that are too big to fit on the screen. But anyway, it's Microsoft's attempt to make a GUI not as good as Ollie Debug. Anyway, there's help. If on the ribbon bar, you can click Help. On the Home tab, Local Help, and now you get a Windows 3.5 chum file, which is, this is the best help. This is the way to learn how to use WinDebug, this thing right here. It is really good, and I have to go back here all the time to learn how to use these commands. WinDebug, you know, might as well be a command line program. I don't know why they even bother to have these windows, because it's really just command line, and you have to type in commands to get everything done. And this is where you learn how to the syntax of these commands. Anyway, so now I can disassemble a function. So I can do this: unassemble function, nt bang, nt create file. Okay, and now it will show me the assembly language, just like you would see it in Ollie Debug, on a less friendly interface. Here's the assembly language. Here's the raw bytes that made that command. And here's the location of that command. And they put an apostrophe in the middle. It's a 64-bit address, but they put an apostrophe in the middle to break it into two 32-bit segments just for readability, which is a pretty good idea, I think. That's the beginning of this command, of that Windows function, kernel function. And so now I can search memory with this kind of command. This is going to search from the beginning of nt create file. It's going to search for this pattern, 44, 24, 40. And I could, here it is. That looks like 44, 24, 50 there. So, you might be able to spot it right in this list. But anyway, I can search for that pattern of bytes with this kind of command. So you can find things in the kernel. And so there it is. It found it. 44, 24, 40 is here, the first instance after the beginning of nt create file. You can also find strings. SA is the command that will search all readable strings. And L is the one that tells it how far to go, so I'm going for a distance of 100 bytes, so it won't be too long a list. And here's all the readable strings it found in that area. It looks like none of these are actual strings. They're just random characters that happen to be printable. All right. And here's another one, which will look for, this is I think an L6 in the brackets to tell it I only want to see strings of length 6 or more. And you can get all the details of these commands in that help menu. Yep, so there I go. I found the only string longer than 6, which also looks like random junk, but It's at least 6 readable bytes of data. So there's some flags you can find here. And then you can look at memory contents with DB. We'll display it in binary and ASCII for both. So DBNT will show me the start of the kernel the way you would see it in Wireshark or in the dump view of Ollie Debug, where I have an address at the left, then I have hexadecimal bytes, then I have ASCII here, and you can see it's like any other Windows executable. It is starting with a MZ tag, and this is the DOS header, and later on will come the PE header. All right, and then you can look at things like file objects. So here's the way you look at the structure of an object, DT, and it will show you the layout of the type called a file object. It's this is a C++ data structure. I used to teach that class years ago. Just a layout of bytes with names and types. So it's an integer here and another integer here, and then a pointer, another integer, and then some characters. And here it tells you how many bytes into the object it is, so you can see what's in there. And someplace down here it's got like file object extension, and it's got the file name up here, the Unicode string. That would be the readable part. All right. You can view the running processes with .tlist. But you have to get it to listen to you the first, though. Okay. These are the processes, the process number, and then the name of the process. The same kind of stuff you'd see in Task Manager or Process Monitor. Process Explorer, I should say. And if you want more details about a process, you can give it a specific process to examine with this syntax. And then it will give you more information about that process, its image, its process environment block, and you can see devices and drivers here. Anyway, the interesting thing is the entire Windows kernel is completely visible to anybody through this interface. Even though you don't have Microsoft source code, you can figure out what the kernel commands do, and you can find bugs in it and so on. And a lot of people do. So here's my instant path, and you can see my drive. My disk is, of course, a VMware disk. And this is something I was just writing something about the other day. This is how malware detects that it's in a virtual machine and then often doesn't run. It looks for things like the name of the disk here. All right. So anyway, that's the basics of kernel debugging. And I think I'll stop this one.